Welcome to The Explainer. Today, we're going to open the doors to the factory that really powers our entire digital world. It's a place that takes the most abundant raw material out there, data, and turns it into the intelligence that shapes pretty much everything we do. Okay, so let's just dive right in. I mean, how does this happen? It feels like magic, doesn't it? You finish a movie, and bam, Netflix has the perfect next recommendation. Or a jet engine flies halfway across the world, and somehow the manufacturer already knows it needs a new part. Well, it's not magic. It's actually a highly structured industrial process, a production line for turning raw information into pure value. So, to really understand this process, we need a map. And in the data world, that map has a name, the data engineering lifecycle. Seriously, just think of it as the master blueprint for our entire factory. It lays out every single stage, from the second those raw data ingredients arrive to the moment a finished, valuable product is shipped out the door. All right, every factory needs raw materials. And in our data factory, the very first stop is the receiving dock. This whole initial stage is just about getting the data in the door and finding a safe, organized place to keep it before it heads down the assembly line. Now, you gotta understand, data doesn't all arrive on the same schedule. Sometimes it shows up in these big planned shipments, kind of like a truckload of parts arriving once a day. We call that batch processing. But other times, it's this continuous, real-time flow of tiny little pieces, a constant stream. And that's stream processing. So how on earth do you manage a literal endless river of data? I mean, you can't just block it, right? Well, engineers use this really clever technique called a D-stream. It stands for discretized stream, and it basically breaks that constant flow into a series of tiny, manageable little chunks, these micro batches. It's almost like putting the river onto a conveyor belt made of small buckets. It makes processing a continuous stream totally possible without getting completely overwhelmed. Okay, so the data's here. We can't just dump it in a big pile on the floor. We need the right kind of warehouse, and believe me, there is no one-size-fits-all solution. Depending on the data's shape and what we want to do with it, we might pick a document database for something flexible like user profiles, or a graph database to understand how things are connected, or maybe a super fast key value store. Each one is a specialized tool for a very specific job. But of course, raw data just sitting in a warehouse isn't very useful, is it? It's like having a pile of wood, screws, and some fabric. It's not a chariot. So now we head to the assembly line. This is where that raw data gets cleaned, shaped, and put together into something truly valuable. This is the factory's main production line, and it often follows this classic three-step process called ETL. First, you extract the raw materials from the warehouse. Then you transform them. And this is where the real work happens. You're cleaning up errors, standardizing things, combining different pieces. And finally, you load that finished, valuable data into a brand new system where it's all ready for people to use. This quote just gets right to the heart of why that transformation step is so critical. Data that isn't used? It's just taking up space. It's costing you money. It's inert. A liability, not an asset. The whole point of this factory is to turn it from a cost into a source of real value. Okay, let's move on down to the loading dock. This is where we see how this finished product gets shipped out to the people who can actually use it. This is where the data finally meets its purpose and starts making a real-world impact. And this is where all that hard work really pays off. The finished data product, well, it can be used in so many ways. It might power analytics dashboards for the company's leaders. It could be fed into a machine learning model to predict what customers are going to do next. Or, and this is really cool, in a process called reverse ETL, it can even be sent back into the day-to-day tools, like a sales app, to make those tools smarter. Think about this in the real world for a second. Companies like Rolls-Royce use this whole process to monitor thousands of sensors on their jet engines while they're in the air. This lets them predict maintenance needs weeks in advance, preventing delays. Or think about major retailers who analyze your shopping habits to predict what you might need next. This is data creating real, tangible results. So we've got our raw materials, our assembly line, our shipping dock. But what keeps this whole factory from just falling into chaos, producing faulty products or having massive accidents? Well, that's where these things called foundational undercurrents come into play. Now, these undercurrents aren't a single step in the process. Instead, they flow through and support every single stage. Think of them like the factory's safety regulations, its quality control systems, and its operational rulebooks. They're what makes sure everything runs smoothly, safely, and efficiently. Let's look at three of the big ones. First, security. That's the factory's guard, basically. Protecting the data, making sure people only have access to what they absolutely need. Then there's data governance. That's your quality control inspector, making sure the data is a reliable, trustworthy asset. And finally, data ops. Think of this as the factory's efficiency expert, applying all the latest automation to the data assembly line to make it faster and more dependable. Good governance often means a really big cultural shift inside a company. The old way of thinking was data ownership, where every department kind of guarded its own data like it was private property. The modern approach is data stewardship. It's this idea that data is a shared asset and it's managed by caretakers for the good of the whole organization. And a huge, huge part of governance is just making sure the data quality is there. I mean, what good is a factory if it just produces defective junk? Quality really boils down to three key questions. Is the data accurate? Is it actually correct? Is it complete? Are there any missing pieces? And is it timely? Is it available when we actually need to use it? So, after all that, why? Why have we built this massive, complex factory? What's the ultimate point of this whole data engineering lifecycle? Let's bring it all home. It all comes down to this: turning a simple digital trace, every click, every purchase, every sensor reading, into an active, powerful asset. An asset that helps a business understand its world better, operate more efficiently, and make smarter decisions at every single turn. It's really about transforming raw bits into better business. And at the end of the day, this isn't just a model for giant tech companies. It's a framework for creating value. In a world where basically every action we take leaves some kind of digital trace, the potential to build these data factories is absolutely everywhere. So it kind of leaves us with one final question to think about. What raw materials, what digital traces exist in your world, just waiting for their factory?